One reason I've always wanted to be standing in front of people to be talking is so that if I come and stand in front, I'd be like, and I'm here with my beautiful wife, and my beautiful wife is here with me, and, and I thank my beautiful wife, you know. But unfortunately, I'm unmarried. Sorry. So I thank the church and the servants and God for this opportunity. Today we would be talking about and discussing blood groups and sickling patterns, right? I know we've heard a lot, obviously, because in the university community, it's something that you should be well abreast with to an extent. However, today I hope that by the time we are done, we would learn something new and so. Yeah. And my name is Nathaniel. Sorry. No, my name is not Nathaniel. My name is Ayerkain. You can call me Nathaniel. It's okay. Right. So let's go. Today we'll speak generally about blood groups. We'll talk a bit on resource factor. We'll look at why it's important to know your blood group. We'll focus a bit on blood type diets. Then how your blood group influences the rate at which you get some infections and the kind of infections you can get. And then we'll move into sickling and then pregnancy. Right. So, the entire human body as it is, right, can be divided and broken down into organ systems. Okay, so we have the digestive system, circulatory system, respiratory, etc. And these organ systems can further be broken down into organs. Okay, so like the heart in isolation is an organ, the lungs, etc. And then you can break down the organs again to get tissues. When we hear tissues, most times we focus more on the solid parts of the body, right? But the blood as it is a tissue. And if you break down the blood further, or if you break down tissues further, you have cells. Okay, cells. C-L-S, cells. So most of today's discussions would be revolving around cells, blood cells, red blood cells specifically. Okay. Now, every red blood cell as it is has antigens. So my headache was how to talk about this so that a social science person will understand. Right? So um, when I say antigens, I mean tags, like name tags or labels, right? That's attached to the cell. Okay. So every red blood cell has antigens. Most red blood cells have antigens. Sorry. So when we are talking about blood group, today mostly we'll be referring to the ABO blood group. Okay. There are a lot of blood groups, but in Ghana, most times we are talking about blood group A, blood group B, blood group AB, blood group O. That is the ABO grouping system. But then there are others. Okay. The resource factor is also a blood grouping system, but we do it in conjunction with the ABO. Right. So now, regarding ABO blood grouping system, the red blood cells on the antigens would determine the kind of group you belong to. If you have a tag A, right, alone, then you'll be blood group A. If you have a tag B on the red blood cell alone, you'll be blood group B. If you have both tags, both tag A and tag B, then you are blood group AB. If you have none of the tags at all, you are blood group O. Are we clear up to this point? So if you have any questions, you kindly jot them down. When we get into the questions section, you can ask them, right? So when God created human beings, He gave us a certain special war response system called the immune system, right? The entire system is responsible for fighting infections. However, It also basically responds to anything foreign that comes into your body. So, for a person who is blood group A, because of that tax, that A tax on your red blood cell, your immune system is forced to produce certain soldiers against those tags. Do you get it? And so if there is a foreign body that enters a cell, that enters your blood in terms of red blood cells, so maybe you have tag A, and then someone has tag B, and they give the tag B's blood to you, your body would know that this person doesn't have my tag, and so it's a foreign, and then we start to fight against it. Right? Good. So that's the blood. Then resource factor. There's a certain story somewhere in the early 1900s, right? Some scientists just woke up one morning and felt like being curious and creative. So they got some monkeys, they called Rhesus monkeys. They took their blood for some reason. They took their blood and then they gave it to some rabbits, mice, and other animals. Saw how they reacted, right? Then they did that same procedure on a human blood. The human blood that reacted had that factor. Okay, so if you have that factor, you are resource positive. It's not a disease, it's just another system of blood. Okay, so that's plus or minus or positive or negative. We attach to the A, B, and O is the resource factor. Are we clear? Right. So then we have blood groups like blood A positive, B positive, AB positive, O, etc. The resource factor is very critical when it comes to pregnancy. Okay. So if I have a tag and you don't have the tag and you give me your blood, I'm safe. If I don't have a tag and you have a tag and you give me your blood, because I don't know what that tag is, I'm not safe. My body will react to it. Okay, so a person who is resource positive, that person has a tag. That person can take blood from anyone who is also resource positive or resource negative. Are we fine? A person who is resource negative does not have that tag. So taking blood from someone who has a tag that is resource positive would be serious, actually. In women who are resource negative on their own, it's very crucial when it comes to pregnancy, especially if they are married to a husband who is resource positive. So, like we've been hearing, blood group A is compatible with blood group A, but that's not the entire story. The positives and negatives also can play. Okay, and so the person that is blood group A negative and her husband is blood group A positive. In the time of delivery, right, the positive trait is dominant over the negative trait. By that I mean, if I have the tag and you don't have the tag, our blood, the blood that we get as a result would have the tag. Okay. So if a mother is negative and the husband is positive, it's very likely that her child will be positive. And in the course of delivery, it happens that the baby and the mother's blood mixes. So when that happens, because the child has the tag, the mother will now produce soldiers, antibodies to fight it. So that first delivery is safe. The mother can deliver safely. But going forward, you might not even conceive at all. If you conceive, you might lose your child. That's why they say if you are negative, if you're one and you are resource negative, and you marry a man who is resource positive, it's likely that you give birth only once, and that's all. It's true to an extent. However, now there is a solution, right? There is an injection we give called anti-D immunoglobulin, right? It's an injection. You have to give it to you so that it balances, So the woman's body will now not see what the child is bringing as foreigners anymore because we've given you the injection, right? So why know your blood group? Why know your blood group? Someone asked me one time that in the olden days, before science, before chemistry, how was transfusion being done? Do you know, to an extent, in the beginning, science was more of try and error. Like, I give you the blood, if you die, you die. If you live, you live. I mean, but now the world has advanced, and it's necessary we know these things, right? So, like I said, you don't choose the blood groups in isolation, as in ABU alone separately, and then the resource positive and negatives too separately, right? So we'll do A positive, A negative, B positive, B negative, AB positive, AB negative, O positive, and O negative. AB positive has all three tags, all three labels. It has the A tag, it has the B tag, and it has the resource tag. That means that whatever blood is coming to it, whether it has the tag or not, it is okay. Are we clear? So people who are AB positive are universal recipients. As for them, unless the blood isn't engine oil, it will work in them, right? A person who is O negative, that person does not have any of the tags at all. So in SHS biology, they don't say O negative. They say blood group O is a universal donor. It's not entirely true. Specifically, it is O negative. They don't have any of the three tags. So it gives feeling. Those people, they are national assets. The problem comes when it is now time for them to receive. Because you can give everyone, but if you want to collect, we'll see where you get your blood from. So for those people, we mostly advise them to donate very frequently. And then sometimes, if they can afford it, they remove some of their blood and have it stored in liquid nitrogen. So that in the future, when you need blood, maybe you donate your blood in Cape Coast, get an accident in Accra. Obviously, the blood can't come there. But if anyone has donated blood before, they give cards, right? And Munchi Mujala, Moon donated blood. They give cards. I am a donor. If you're lucky, you get Milo. If you're lucky, you get T-shirts, etc. But then the cards is the most important thing. If you're a donor, your card will show how many times you donated, your blood type, etc., etc. So if it comes there, you'll be safe, right? So the chart is not too clear, but let's try our best to see, right? The row above is the blood types of the donors, right? And then the column at the left is for the recipients. So you just match it. Wherever you see the blood, it means transfusion is possible. Okay. So O minus can give to all. O minus can give to all. I hope you can see. Like top left. This one. That's O negative. O negative can give to all. O positive can't give to all. O positive can only give to the types that are also positive. So O positive person, you can't give blood to a person who is AB negative. You can't give blood to a person who is B negative. Are we fine? A person who is B positive can give blood to a person who is B positive. A person who is B positive can give blood to a person who is AB positive, but cannot give blood to a person who is AB negative. Please, are we confused or we are clear? Are you confused or we are clear? Hello? It's not rhetorical. I want a response. Are we clear? We are clear. I should come again. Great. There are 8 different blood groups according to the ABU and Rhesus system, right? We have A positive and A negative, B positive and B negative, AB positive and AB negative, O positive and O negative. If you are negative in any sense, you can't take blood from a person who is positive. If you are positive in any sense, you can take blood from a person who is who is either negative or positive. If the group fits. Do you understand? So a person who is blood group B negative can't take blood from a person who is blood group B positive, even though they are both in the same blood group. Are we clear? Right. Modern cell phones now have emergency information somewhere in your settings. Some of you have never seen that before, but it's there. That emergency information comes to your name, emergency contact. You find out what your blood type is, and you add it. Okay, you add it. Though you manage it like just a little, right? So your phone's emergency information can help. Worst case scenario, if they can't get to know what your blood type is, they'll give you blood group negative if it's available. Okay, so let's do what to get to know. Then my favorites, eating for your blood type. So there's a concept called blood type diet, right? Where people say that if you are blood group B, you must be a vegetarian. If you are blood group A, don't drink milk, don't chew cashew nuts, don't eat sausage, etc. One time I was in a bus from Kanishi to Takrade. Then this man was selling black seed and was preaching. He was preaching medicine. Like, your blood group AB. That's what I mean, because me can't that out. Mama, you are negative, so I'm going to you the the same way. If you need to go out, say the way then you shake black seed and then your mouth. Well, at the moment, it's false. Everything in and around us is a poison. The only thing that keeps us alive is the amount of it, right? Even water, like raw, harmless water, not mixed with anything, at a certain quantity in your body can kill you. Okay. As I spoke about earlier, these antigens on the red blood cells contribute to the weight of your blood. It contributes to the viscosity, the thickness, how thick your blood is, right? So a person who is blood AB, because the person has both tags, their blood is thicker than a person who is O negative. Okay. Now, if you have muddy water, thick mud, poor mud water, and you have coconut water, right? They both contain certain things, but if you sprinkle a little bit of sugar, or you put a cube of sugar inside the muddy water, and you put a cube of sugar inside the coconut water, the rate at which the sugar will dilute and be mixed in the coconut water is faster and simpler than in the muddy water. Okay, so the assumption is that thicker blood is able to dissolve and assimilate certain substances faster. Sorry. Lighter blood, right? Lighter blood, that's the assumption. Lighter blood is able to dissolve and assimilate certain substances better than thicker blood. But it's not true. You know, I mean, if we all drink orange, I don't think we will have a taste. However, the amount of orange you consume has an effect on the amount of vitamin C you get out of it. Has it? Unless, of course, you are allergic to something, which is not related to your life. You are hypersensitive. Some people, the cheap planets, they get headaches. I don't know what hypersensitivity is, but it says that some are lactose intolerant. So when they take dairy products, they have some reaction to the not that they have nothing to do with your life. This is the thing. So like for example, you don't understand what you're saying. If you're into a farm, yeah, a guapo jam. Ask the person if the person is talking about iron containing cubes like contobre or spinach, agave and spinach. And it was the iron. Ask the person if the person is talking about or meat stuff. So that you really want it. If not, if you're in India, dear, it's wow. It's up to you to choose. On the other hand, blood groups actually have an effect on certain infections, like malaria. So, I had a game one time, very recently actually, that people who are black who get severe malaria. Someone said that. Won't say that. Won't say that. Even I won't. Any other answer. So, the antigens I talk about, those labels, those A and B labels, A B labels, right? Yeah. Right. So the human body, right, has a transport system responsible for carrying oxygen to all other parts of the body. That's the basic like of blood. A specific part of the blood responsible for that is the red blood cell. Okay. And the molecule of the red blood cell, that's is hemoglobin. Okay. Hemoglobin is what makes red blood red. Hemoglobin is why crab's blood is not red. Right? A. No, sorry, it isn't. This is crab's blood actually, but we have hemoglobin, but a different version, cyanide hemoglobin. So, this very substance hemoglobin, right, is part of what the plasmodium parasites and mosquitoes feed on. So if you are infected with malaria, the parasites in your body are actually destroying your red blood cells. Active. Okay. It's one more settle. Now, when you have one more settle. Now, more malaria. Now, we need some more malaria. Now, we move on to the control of the food. Actually, killing yourself so because the malaria parasite infection is destroying your red blood cells. And these will improve them so that the body is actually able to produce more red blood cells. So you are not feeding yourself to get appetite. Feeding the malaria parasites to kill them. That's why it's sure, yes, you have malaria. All the time, sure. We will say, you have malaria and symptoms. Ninja, malaria. It is medications. Right. So, in order for the parasites to destroy themselves, right, they have to attach themselves
To these types, I spoke about earlier, the A and B and the types. They are like handles to a door. Okay. So the malaria parasite must have to hold that handle to be able to open the enter itself to the shore. So the lab types that have those types actually end up getting more severe malaria. Meaning, for example, if you are old, if you are old age, you don't have any of the types, right? So even if the parasite is there is no handle for it to use to open the red blood cells to enter. There is no label there. Okay, so a person is full can get malaria all right, but its severity is not as much as it would be in a person who is sick, in a person who is sick, in a person who is sick. For a person who is sick, they have a tax rate, but let us say this, or one is to have account in 200, and then it gets more severe. Severity is different from infection. Maybe you are not supposed to so among all of us, right, in the world, 80% of us secrete our antigens, our labels of the 80% of us secrete. What does this mean? I mean, it shows itself in our saliva, it shows itself in our sweat. So here that A, I did that A antigen should be only the regular cell. But the distributor will also show those antigens in their sweat and their saliva. Okay. Good. So a person who is old, a person who is old, if you remember earlier, I said a person who is old does not have neither A nor B labels, right? Good. However, they have H. H antigen is just an immature form of either A or B. Okay. So people who are H, who are old and secrete H antigens, for some reason, the sense is like some pheromones to mosquitoes. So all people who secrete H antigens
Attract a lot of mosquitoes. Who I'm not even sure. Old people attract a lot of mosquitoes because of the. Sorry, let me rephrase. Old people who are secretors attract a lot of mosquitoes. Okay, so then in terms of attraction, AB will not attract more than A, then B, then O. But in terms of severity, it is the opposite. So, me, I am O, you are AB. You can be walking around in the same environment always, right? My body attracts a lot of mosquitoes. Like, I get bitten a lot. I'm there normal, like normal. Your body doesn't attract, but some 5 to 10 bites na UCC word, then you are lying there. Okay, so let's get there. So in any say, go for no malaria type one actually. Okay, yeah. So besides malaria, there are other diseases and other infections that are also linked to blood types. However, there is no scientific proof of this word, I don't know how else to say it, of pathophysiology. So, see the way I said old people attract a lot of mosquitoes because of certain things they secrete, right? We can't really identify why, for example, the blood group A people have a higher risk of getting serious COVID-19 infections. So it's like there was a study during COVID-19, right? And they gathered a lot of people who were seriously ill and they checked their blood types. And at the end of the day, the A people were paid. Are we clear? There are other things, however, like stomach ulcer. There are other things like stomach ulcer. Certain blood groups have a higher affinity to stomach ulcer than the others. If I explain, you will get lost, trust me. So let's go on. Okay. Right. So besides the ABO, there are a lot of other blood groups. A lot. But the only man say we are blood group A, we are blood group, we are blood group. That's not all. You can have Kel's blood group. You can be Duffy positive, etc. Recently, they've discovered a new one called Guada negative. Guada negative, unfortunately, is just one woman that has it, and she lost both of her children, and she has some brain issues. So sometimes I wonder and I ask God, so this person, like, let's just say the person needs blood, like, urgently. What is the person going to give blood for? You know? So sometimes in the hospital, someone needs blood, right? I remember last year there was a man from Tanzania came to interpret. He needed blood, okay. And then we did cross matching. So cross matching, we are taking the donor's red blood cells and we are putting it in the recipient's blood to see what will happen, but in front of our eyes, not inside the person, right? So the person was blood group B positive. We had B positive blood. We had O negative blood. We did cross matching and they were all not matching. It was weird. And it is at that point that the professors came inside. Like, I was impressed. The way they were able to realize that there's an extra blood group. So they have to take the sample to Uchi to go and do some Manema P, right? So we can be here normal. I'm blood group O positive, but there might be an extra, which might be a contributing factor when I'm receiving blood. So we've already said that if you are blood group O negative, you can give blood to everyone, but you can be blood group O negative. Have another blood type we are all not aware of, and you will be disqualified as a universal donor. Are we fine? So it is not really as it's not really about ABU and resource raw like that. Nah, it actually goes to a further extent. Okay, so that's what we have on blood groups. That's what we have on blood groups. Let's move to sickling. When we were younger, even when I was younger, I always thought a sickler was a person who was in primary 4 and had saliva coming from his mouth. That's what I thought. Not any other class, but class 4. And had saliva coming from their mouth. And then sometimes you see, I think it's class 4 you start using pen to write, right? So you see them penning their addresses in there. When you're talking to them, they look lost. That's why I thought it's a class, but it's not too far from that. It's actually very far from that. So, however we see ourselves now, or as a result of certain coding in our system, right? The reason I am short, say I'm short. You say yes, I told that. The reason I am short is because of a certain coding inside me. A coding which was passed to me from my ancestors, wherever they are, their souls rest in peace. And which I can also pass to my descendants, wherever they will be, may they be great. You know, say amen. Right. So that That coding or the codes are the genes. Okay, the codes are the genes. So how the code looks like is the type of the gene, so the genotype, right? What the code would result in, as in tall, short, obolo, chingelinge, is phenotype. So phenotype, Pheno type, is what we can see with our eyes. It's the end product of what the gene coding results in. Okay. So the genotype is like an instruction. Be blue, then the phenotype will be blue. So we see blue. Okay. The hemoglobin we spoke about, which was responsible for transporting oxygen across the body, right? Actually comes in types. It's not just one type. It's not just one. There are variants because of the different codes of genes, because of different genotypes, right? So ideally, we've sorry, I drank Coke, so it's doing my throat gas. Ideally, ideally, the word genotype alone shouldn't refer to sickling. Right now, you walk into the hospital and you're like, Doctor, I'm checking the genotype. They won't ask you any question. They know exactly what you mean. But ideally, that should be the case. Ideally, of course, the person checking the genotype, but they should ask you genotype then. People say seeking genotype, height genotype, obesity genotype. Do you get me? Huh. So from now, let's our language advance. Don't just say genotype raw, add sickling. So sickling genotype, right? Now, this instruction, there's the normal and there's the abnormal, and there's the mix. If the gene is able to tell your red blood cells that the hemoglobin you are producing, let it be A, then it is A. A is normal. If due to certain mutations, it's unable to do that, then you end up having S. When I said S, some of you are sad. Now, a gene is actually double-stranded, right? It looks like two ladders that are soft and have been mended together like a twig. Okay, that's what the gene looks like. The codings, you take a certain part from your mother and you take a certain part from your father, right? That is why when we are writing genotype, it's likely you see two alphabets. So one of the alphabets you got from your mom, one of the alphabets you got from your dad. It's not something you can choose, it is given to you. So whether you like it or not, if you are AS, if you are SS, go and blame your father or your mother. Right? You don't get to choose it, it is given to you. So we have genotype AA or A, which is normal. Then we have AS. Those people are carriers, they have the sickle cell trait. Then SS, full blown sickle cell. Then SC is also a form of sickle cell, but it's a bit milder, right? We'll get there. So, people who are AA are normal people. When I say you're a normal person, it doesn't mean that if you don't take care of yourself well, you will fall sick. Please don't get that wrong. It doesn't mean that because you are not a sickler, you don't fall sick. You can fall sick like anybody else. Okay. However, the natural predisposition is you don't have the sickle cell trait in you. So AA is normal, right? Then AS. The AS people have borrowed one A from their father or mother and one S from their father or mother. So it's a mix, right? If they are giving birth, they can pass on one A to any of their children. They can also pass on one S to any of their children. Then the critical one, SS, full-blown sickle cell disease. Full-blown sickle cell disease. Can you please go back to the previous slide? Previous. Yeah. So those two diagrams there, on the right and the left, right, are how your red blood cell looks in your body, right? A normal person with a normal genotype AA would have that round biconcave shape. Okay. You see, the blood in our body actually passes through certain pipelines. Okay. Some are arteries, veins, venules, arterioles, and capillaries. They all have different sizes. In order for the red blood cell to be able to pass through all these different sized pipelines, it should be able to bend, unbend freely. It should be able to be flexible. It should be able to squeeze itself so much so that it can enter the smallest capillary. Are we clear? People who have the normal traits can freely do this. For them, their red blood cell can swim into any capillary at all. People who have full-blown sickle cell, their red blood cells, under certain conditions, end up looking like a sickle. If you've gone to the cocoa farm before, that's, if anything, aso and I, so. If anything, oh, even anything cocoa, I say, a moon half, right? So the sickle cells have a crescent shape. And that thing they used to plug cocoa is called a sickle. That's where the name came from. Now, these people, they are unable, their blood cells are unable to fold and unfold. Right? They're actually very hard sometimes, like very, very hard. And then they clog the spaces of these pipelines. So they block the spaces. When that happens, blood can't move to the other side, and then they begin to have crisis. So if you take the blood of a sickler, like you just take the blood of a sickler, and you put it under a microscope, raw, without anything, maybe you mix it a little normal saline, right? And you look into it, you not see a sickle-shaped cell. You see a normal red blood cell looking around like that, a sickler. These people, it is when they are oxygen deprived. It is when a certain species of oxygen called reactive oxygen species. It is when there is oxygen stress on the red blood cell. That is when the red blood cells become like that. So in cold weather, when they are dehydrated, sometimes when they are pregnant, but when you are pregnant, your body consumes a lot of oxygen naturally. So there's that stress of oxygen. If you've lived in Accra your whole life and you're a settler and you decide one day to wake up and travel to Tamale, you get crisis. Because the altitude there is different. The oxygen concentration there is different. Are we fine? Then we have the traits, the carriers, the AS people. Okay. People who are AS on the outward look normal. No, actually everyone looks normal on the outward. But what I mean is, people who are AS, they are almost like those who are normal, yet they are still almost like those who are sickless. So for them, it is under very extreme conditions that some of their cells would temporarily get that shape for a while. So If you're a carrier and you like running a lot, Johnny, son, Johnny, it is oxygen stress, extra oxygen stress. You can just collapse there, back, and you'll be born. As a carrier or a sickler. Are we fine? Yeah. However, we'll get to that. I think there's a section on sudden death and good. Now, there's also a certain genotype traits, AC, SC, those ones. Hemoglobin C is not sickle cell. If you are AC, you are not sickle cell. Hemoglobin C is just another genetic variant of hemoglobin A, right? And it is very, very popular. It is common in West Africa. So Ghana, Senegal, Burkina Faso, Mali. If you go, you see a lot of people with hemoglobin AC. It's normal, right? And there is also hemoglobin CC. It's like you have someone who's SSAA. Someone can also be CC, which is very weird and very dangerous. Because those people actually cannot, their red blood cells cannot carry the enough and right amount of oxygen that the other parts of their body need. Okay, so hemoglobin CC, it exists. Hemoglobin AC also exists. The most important part of knowing this to me is because of marriage and pregnancy. You see, in the families we have, right, our spouses are actually the only people we get to choose. Like, you didn't get to choose your brother, he was given to you. But your husband and your wife, you get to choose. But still, you get to choose. You know. And this sickle cell thing, most people who are full-blown sickle cell, they don't live long. Most of them don't live long. Someone who is a carrier, if we have some here and you like very, very benevolent enough to share an experience of a mild crisis, you'll be surprised. Carrier, not someone who's like full-blown sickle cell, just a carrier. Sometimes their crises are like very, very serious, and you wonder if they're actually carriers and not sickle cell. And then knowing very well that if I marry this person, there's a likelihood that one of our children will be full-blown sickle cell, and we still go ahead to do it because of love. So, for a couple who are either, one is AS and the other is also AS, for each pregnancy, there is a 25% chance of them having a normal child, A. There's a 25% chance for them having a sickler, SS. And there's a 50% chance of them having a career. And when you tell them this thing, they start smiling. If you ask them how, they tell you at least 50% a career there, it's better odds, it's over 2.5, so it's better. Some also have the perception that if they give birth once and that child is SS, then it means that all the other children cannot be SS. It's not true. You can have 4 different children and all 4 of them will be sickless. So this probability, this ratio, is for each pregnancy. So for 2 different careers, AS, AC, 25% chance of having a normal person, AA, 25% chance of having a career, AS, 25% chance of having AC, and then 25% chance of having SC. Now, people who are SC are also sickle cell, but their condition is a bit milder than SS people, just a bit milder. Okay. And then if two people with AC decide to marry, I mean, maybe they want to gamble. It's fine. We'll see what happens if they give birth to a child who is CC. I've not seen some before. I hope I see some. I want to see someone who is CC. So you AC, you meet AC, there's 25% chance you get AA, 25% chance CC, and 50% chance of having AC, right? So like I said, if you live here today, or you are going home, ask your boyfriend and ask your girlfriend, what is his genotype? What is her genotype? Some know, especially those into medicine. Some know, those in medical school, pharmacy school, they know, Jethro. They know. They know, like they really know. But, and some of them actually stand in front of people to advise them, like I'm doing. But when it gets to this, it's just hard for them to let go. Like, dating is not marriage, you know. Don't waste your time catching unnecessary feelings for a very long time. Actually, for me, this is something I asked like in the first 2 weeks. What's your genotype? Yeah, if it doesn't work for me, I'm going my way, like on to the next. Right. If you've been together for 3 years, it's not too late. It's actually not too late. But you cry, you don't even know what it is. What do you have to say if he or she asks you? I mean, so like let's make the effort of getting to know what our genotypes are, right? And then people who are sickle cell, aside that pain crisis they have because of the cells clogging in their vessels and stuff, they are actually very susceptible to a lot of infections. A lot of infections. And it is very serious. It's not your malaria, you are on the bed for 3 days, you can't eat. You are not that. Very serious infections. And the amount of money you need to take care of those people alone, the mass as a better as I say account. You know, so this is the time to make the decision. I mean, I can't directly tell you that like you are AS and she's AS, so leave her or leave him. No, I can't do that. If I tell you leave him and you listen to me and you go and leave her and you're not getting some again, come and tell me that men are say leave her. No. So we just open your eye to the reality and then you make your decision. However, however, if you make a decision and it doesn't favor you, it will favor me. Because you come for us to treat you and you pay. It will not be free. It's actually very expensive. Very expensive. People who were AS once upon a time were not really moved by malaria. Say after that. I could be AS, the malaria channel, malaria channel, serious, those things. Once upon a time it was true. Now it's not true anymore. People who are AS. So the malaria parasite has now length, length, length. The malaria parasite has now length, right, and has adapted to what the AS people had that was not allowing them to infect them, right? So now, if someone is AS and a person gets infected with malaria, that person can be a weapon. Because if the parasite enters your system, right, the there are stages the parasites move into, like a mosquito, egg, larva, pupa, adult mosquito, right? For the parasites, they have stages as well. Gametophytes, etc., etc. Uh-huh. That gametophyte stage is the stage where active infection occurs. And for some reason, people who are AS, after getting infected, they just breed that gametophyte phase of the parasite. So a person who is AS, even if the person is asymptomatic, the person is not showing symptoms of malaria, or the malaria the person has is not affecting him or her the way it's supposed to. If a mosquito bites that person, carries the gametophyte phase of the parasite, and comes to bite you, it will be very severe. Because that phase of the gametophyte is bringing is one that has adapted. It's not the normal one, Sam. That is why, I was about to say, that is why the second phase of COVID-19 will be very serious. Because the vaccine has come, it has learned, and it has adapted, and it's coming again. This time, it's coming with, if it came with a bus the last time, this time it's coming with a jet. So that plan you plan to kill it with, they will not work. You get So now that is how the parasite is now moving in people who are AS. Right. Then again, there is another genotype which is a bit silent in sickle cell. It's called alpha thalassemia. Alpha thalassemia. The hemoglobin, as we have it, right? After the genes do the coding, there are 4 different chains, right? That will be combined so that you end up getting your hemoglobin. One of the chain, one part of that 4 component chain is the alpha chain or the alpha globulin, right? People who have alpha thalassemia actually make less of the alpha globulin. Just as we have a carrier sickle cell, full-blown sickle cell, we also have people who carry the alpha thalassemia traits. But that one, it's in percentages, you know. There are some people who carry it, but silent, no symptoms, or okay. Some too, very severe. Some might require blood transfusion very, very often. It's also there. So, aside asking her what is her genotype, I have to ask her if she has a alpha thalassemia. If you forget, write it down. So, as you text it to her on WhatsApp. If she asks you what it is, tell her to ask AI. Right. Now, sickle cell trait and sudden death. So, almost a month ago, a friend died in Accra playing basketball. Was playing basketball like actively running, then charge. Ghanaians, Kambeka draws. The guy was gone. So, I mean, sicklers at this point, we understand, have like a higher natural predisposition to negative news. When I say negative news, like sickness, death, like those things. However, a person who is a carrier can actually die during sports. It is not due to heart attack. It's due to excessive muscle breakdown. Right? So the oxygen that is moving in the body is moving through the red blood cells. It's moving through the blood, right? In order that your muscle gets enough energy to carry you while you're running, enough oxygen must be transported there. People who are carriers, as I said earlier, under excessive stress, eh, under excessive stress, end up sometimes having their red blood cells in sickle shape. So what happens is, Johnny, name can but or call, killer minded, or then the muscle just breaks down. That's all. Collapse and it's gone. No. However, there's a solution to it. I mean, oh yeah, now so what to say what prayer you hydrate properly before, during, after exercise. I mean, that's those drugs, those drinks, rash, storm, that helps you make you overactive, over enhanced. Do what to avoid them. Okay, do what to avoid them. So we've looked at blood grouping, we looked at sickle cell. Now let's talk a bit about the effects sickle cell people have on us as a community and as an economy. Fortunately or unfortunately, they push a lot of money into the healthcare system because like they require a lot of treatment, you know. Some take and hydroxyurea very often. In fact, now there is gene therapy for sickle cell. So you go to some consultants when people are coming to get married and they are going for a marriage counseling at the hospital, and they go and they realize that they are both carriers, and there's likelihood they will give birth to a sickler. They can tell them that, oh, don't worry, now there's gene therapy. Even if you give birth to a sickler, you can do gene therapy for the child, and the child will be fine. We also have a bone marrow therapy replacement. You can scrape off the red blood cells, the reticulocytes in your bone marrow, and give you new one, and the child will be fine. But it is not free. You know, it is not free. Frequent hospitalization, chronic pain, that stigma, you know, that stigma, that class 4 child who always has saliva coming from the mouth. Sometimes you'll be missing school. When it's raining and the weather is cold, they are just there, covered themselves, folded their legs and everything there. So, if you really love your children and you care about your husband's finances, the both of you,